I'm Saurav Biswas, and my co-author is John Evangelatos. Thank you for the opportunity to present our results from the ground gravity survey in the Guelph area. The purpose of this gravity survey is to interpret the data and help find buried bedrock valleys. Gravity survey works best when there is a density contrast in the subsurface. Here is an example from the Burlington Bar area in southern Ontario. The south to north station locations and the gravity profile is shown here. A gravity low is observed here. On the right, I have a model of the subsurface. The overburden sediments have generally lower density compared to the bedrock. Hence, there is a density contrast. The calculated gravity anomaly from the model matches the observed gravity data relatively well here. The gravity anomaly low coincides with the potential Thalweg of the buried bedrock valley. With this background, let's look at the Guelph area gravity data. The survey area outline is shown here in black, along with the pre-existing gravity data from the OGS in the region. The Guelph survey fills a gap in the data. The gravity data lines were collected along these 17 lines at 50 meter station spacing. The line numbers are noted here. Total 3,394 gravity stations were recorded in this survey. Here I'm showing some of the important channels from the gravity survey in profile format from line 8 as an example. The red dots show observed gravity, the green dots show elevation, the pink dots indicate free air gravity, the light blue dots represent the Bouguer gravity for density of 2.1 grams per cc. For interpreting the potential Thalwegs of the buried valley, we are interested in this subtle low features in the Bouguer gravity. For enhancing those subtle low gravity anomaly features, we first calculate the regional of the Bouguer gravity and then subtract it from the Bouguer gravity to calculate the residual. The residual can highlight the subtle low gravity anomaly features. In this study, I used two methods for calculating regionals. Here are the plots from regional 1 and regional 2 and the corresponding residuals. Please refer to the abstract for more details on the two methods. This slide shows the residuals from regional 1 in blue areas. The background is bedrock elevation. This slide shows the residuals from regional 2 in pink areas. The residuals are a bit more focused than residuals from regional 1. After analyzing the residuals from regional 2 in profile format, I have identified some potential Thalwegs and have plotted them here in green symbols. Next, I will zoom to these two areas in the north and south and have a closer look. This is the northern area. Here, I have overlaid a drainage layer to help review the potential Thalwegs. The potential Thalweg plots should be evaluated with existing drainage features and local geology like quaternary and Paleozoic layers for identifying targets for follow-up by drilling. To clarify, only the plots of the very subtle potential Thalwegs are shown. In other words, for example here, where a prominent pink residual is overlying an existing drainage feature, it does not need verification with drilling. Similarly, I have shown the results from southern area here. All the data and the results from the Guelph gravity survey have been published as GDS 1090. It includes all the channels along the 17 lines, corresponding grids, both in GeoSoft and ASCII formats, and a report. The GDS is available for download from Geology, Ontario. Thank you for your kind attention. With this, I'll stop for any questions.